Okay, so we will go over the push-relabel algorithm and how this algorithm works. So we have this network, okay? We'll work on this one. You can see the flows, and I mark in each one the height and the axis of the flow. And here you can see for each one of them is the capacity, okay? So here you can see the height, the axis, and the node name. So A, B, C, D, E, and T. So there is no E, but S and T anyway. So this is the source, this is the sink. Let's go. Okay, the first step is to initialize the flow to A and C. So for what we basically do is initialize the flow to be 15. So meaning we have this graph because this is the residual edge backwards. So this is 15, this is 4, and now we have the axis in both of them. Here is 4 and here is 15 because this is the capacity. Okay, then we'll go to the next step. Now we have to choose between which one of them we start going. Usually it doesn't really matter, but you choose the one with the lowest height because they have the same height. It doesn't matter, but if they are different height, you have to choose the one with the lowest one. So anyway, we choose this one. It's totally arbitrary, but you can do the same to C. Anyway, so I choose this one, and then what happened is I'm looking at all the edges that they have, but fortunately you only have one edge that is valid, which is this one. Okay, because now this is a residual one that go backwards. So we're not looking at him, so it's basically disappeared and we cannot use it. So now we're looking at this edge. And what we can see that we need to calculate the flow that we will have. So the flow will be the minimum between the edge capacity and the axis we have at A. Okay, so the edge capacity is 12, and the axis we have is 15, meaning the total axis will now be 3, and we will have an edge from here to here, from A to B, with 12. So now the capacity at B, the axis at B, will be 12. Okay, so we have the axis here and the axis here, and we have to remember to increase the height. How do you know by how much to increase the height? We choose the minimum of all the edges and we add 1. So here you can see that the axis is become the axis that we had before minus the axis of the edges. Okay, so we choose all the capacity of the edges and we just remove them because this is the maximum we can choose. And now we have B dot axis is the flow. Okay. Okay, so now we have this one. So we will continue the algorithm, but from this node. Remember, we can also start from here after this step, but just to be simpler, I will keep going from this node. So here we have this B node. So we pass flow from B, okay, which is this node. And then we have to pass the axis to here and here. So this is go to 3 and this is go 7. So we pass the maximum 7 here and 3 here. So we have the axis will be 2 after this pushing, and the height will increase to 1 because this is the medium between both of them. And the axis here will be 7 after that. And here, because it's the sink, it doesn't really matter. There's no axis. So we will see that. So here the residual path. Okay, it's become here 7. The height will increase to 7. The axis here will increase also to 7. And the height will increase by 1. So it will be the minimum between T and C. So the minimum is 1, the height. And that's it. So now we'll keep going from C. Okay, so C, we'll start from C because this is the edges we have. So we go from C. We look who is his neighbor that we can push flow to. So we can push flow from C back to B, residual. But we can also push here, if you can see that. Okay, so what we will see that we cannot really push the flow here because the height is different. Okay, so the height will have to be increased in order to do that. But because this is a residual path, we cannot really do it. So anyway, and the height is different. So anyway, um, actually it's not quite accurate. We cannot push the flow because we have to choose the minimum between them to increase the height. So here the minimum between is h, which is 0, and h, which is 1. So we increase the height by 1 because this is the minimum. So it's h0 plus 1, which is h1. We increase the height and we push all the flow we can here. So we push all the flow we can here, which is we can push 7 here, and we will have 7 back, but 3 that we can still push here. So just so you remember, okay, I put here the path. So here now the axis becomes 7, okay, and now we increase the height by 1. So we keep going here. Now, after we go in here, after we went here, now we'll do the same. So we'll look who is the two neighbors. Okay, we can push all here or here. How do we choose? The minimum height. The minimum height is 0, meaning we will increase the height of this by 1. So h will be 1. And now we can push all the axes we have here. Okay, and how much we have? It's 7. Okay, and we're not limited by the capacity because the capacity is bigger than the axis. So we'll push everything we have here, and we can still put 3 more, but we don't have where to take it from. So here's what we see, and we can choose B or A. Okay, pass 3 flow back to S, and A dot H will be 7, and A dot axis will be 0. Okay, what we see now is after we finish this one, we will have to look back at all the nodes we have and basically adjust the height. So what we can see is A can push back 3 axes back to S. Okay, and then we increase the height of A to 7. Why 7? Because it's S plus 1. Okay, we look which is the minimum which you can go to. So A basically have this is the minimum. So we choose A and we take the axis which is now will be 0, but we push back 12 and we still have 3 we can push. Okay, now we pass back to B, okay, to flow. Okay, so what does it mean? B still have an axis, so we still go over B. Okay, remember, after we finish all of the looping, we go over all the ones that have axis. So I first start over A, but then we go over B. So B, okay, had 2 axes. What does it mean? That you have to push back. So B will push back here, okay, to A, and because it pushed back to A, now the height will have to increase to 8. So it's 7 plus 1, which will be 8. And then he will push back 2. And then A will have an axis, okay, of 2. And then A will push another 2 over here. So this is what will happen. So we can see here already drew it. Okay. Eventually, after this, now we have the axis of 2. We have to increase the height again, okay, by the minimum. We don't have to increase the height because this height is bigger than this one and we can push. So we push the 2 here, and that's it, we finished. So we will have that we push 10 over here, and we have residual pass still of 5. Sorry, I think I deleted some. Anyway, So this is what we get, and we will get this as the final answer. And how do we know when to stop? When we have no axis which is bigger than 0, and we finish the algorithm. So hope you like this video. I'm sorry I don't have time to edit it and fix all the small errors and the during the video, but I hope you like it, and please subscribe and like and ring the bell. Anyway, till next time, I'm out.